Hi guys, in today's video we're going to look at what is nuclear magnetic resonance, TMS, chemical shift measurements, the use of solvents, and finally an exam style question.
So what exactly is NMR? Well, NMR stands for nuclear magnetic resonance, and it's an analytical technique. It works on the principle that nuclei with an odd mass number, such as hydrogen or carbon-13, have a spin. Now, they produce a magnetic field rather like a bar magnet, and when an external magnetic field is applied, these nuclei will either align or oppose with this external magnetic field. And what happens is the aligned nuclei will absorb energy, and this causes them to flip. And you can see a diagram of the apparatus we use here, and it shows that we actually use radio waves to input this external energy and create this external magnetic field. Well, the energy required to flip our nuclei is called the resonance frequency, and we can measure this resonance frequency and graph it, and it's detected as a signal. So this signal is what we call a chemical shift. So each atom, either a hydrogen or carbon, depending on whether we're looking at proton NMR or carbon NMR, will produce a shift, and this shift depends on its environment. It depends what it's surrounded by. The units of our shift are ppm, or parts per million, and it's usually given this symbol that looks like that. Now, the shift is given relative to TMS, and we'll have a look at TMS in just a second. But it's important to note that the more different the structure is, or the more different the environment is to our TMS, the further away from this reference point it will lie. So, what is TMS? Well, TMS stands for Tetramethylsilane, and it has this structure here. You can see it has a central silicon surrounded by 4 CH3 groups. This is used as a reference point on our NMR spectra. That's for many reasons. The first is that TMS is unreactive. The second is that you can see it has 12 hydrogens in the same environment. You can see from symmetry that all these hydrogens are in the same environment. They're all attached to a carbon, which is attached to a silicon. Similarly, all the carbons are in exactly the same environment.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level chemistry videos, click the button. Join me today and together let's make A-level chemistry a walk in the park.